I'm Ravin, and I will present introduction about human-computer interaction, which is a discipline that focuses on how people interact with computer-based systems, including everyday household appliances. In modern context, HCI extends beyond traditional computers to encompass all devices equipped with user interfaces that require input, decisions, or operational control from users.
Let's look into the two types of product architecture and interface design commonly used in microwave ovens. On the left is the analog or mechanical interface. It uses physical dials and switch to control the time and power, along with fixed function buttons and a mechanical start or stop plunger. Input is direct and continuous, meaning each control maps directly to a function. This makes the interface intuitive, easy to use, and reliable, especially for users who prefer tactile feedback. On the right is the digital or menu-driven interface. This design uses a membrane keypad and a LCD display. User enter the setting through the numeric keys and dedicated function buttons, while the display provides a visual feedback. Input here is discrete and sequential, requiring user to follow the menu-based commands. In summary, the mechanical interface focuses on simplicity and direct control, while the digital interface offers the greater flexibility and advanced feature to the software-based control.
This video explains task analysis for heating food for 1 minute 30 seconds using microwave. I will compare analog and digital interfaces. For analog microwave, the user places food inside, turns the knob 1 minute 30 seconds and heating start. The task is completed when the times end and it is very straightforward. For digital microwave, the user places food, press the time button, enters 130 and press start. When heating finish, the task is completed. To compare, analog is simple and fast, while digital is accurate but needs more steps.
So this commercial highlights the ergonomic visibility of the microwave design. From a front view, the LCD display is clear and easy to read. However, when viewed from wider angles, the LCD contrast fades, making information harder to see. In comparison, printed buttons remain visible from the side or any lighting. When simulating poor eyesight and glare, the display becomes less readable, especially for elderly users or in bright environment. This shows the importance of clear visibility and ergonomic design in everyday appliance. So next is using Gestalt principles on the microwave. So the frequently used button must be easy to use. The buttons are grouped by function to make it easy to identify. Related buttons are grouped closely and start and stop button is clearly displayed. This will improve the usability and reduce confusion of the user.
On the left, we have the analog microwave. It uses large rotary dials, about 5 centimeters in diameter. The controls are clearly separated, one for time, one for power, so user don't have to think too much. There's a very little visual clutter, which makes it intuitive and easy to grab, even without precise aiming. On the right is the digital microwave. Here, we see many small membrane buttons, roughly 1.5 centimeters wide. Preset functions like popcorns are mixed with numbers creating high visual density. This means user must visually search and place their finger accurately before pressing. To compare this objectively, we use Fitts law, which measures how difficult it is to reach a target. Assuming the same hand-to-control distance of 20 cm, the digital button has an index of difficulty of 4.74, while the rotary dial is only 3.0. So in simple terms, smaller buttons are harder and slower to hit, while large dials are faster and more accurate. The user actually know their input work. On the left is the analog microwave. When you turn the dial, you immediately feel physical resistance and clicking. At the same time, the dial position change, giving clear visual feedback. So the user instantly feels and see the input, which result in low error and low frustration. Now on the right is the digital microwave. Here, the buttons are flat membrane controls with no haptic feedback at all. There is no physical confirmation when pressing a button, so user only know the input work after hearing a beep. This often leads to a common problem, where users press the button multiple times because they are unsure. As a result, uncertainty increase error and frustration, especially for elderly or first-time users. So from a feedback ergonomic perspective, analog controls provide clearer and more reliable feedback.
Effective ergonomics performance is built on 4 key pillars: simplicities, focus on making control intuitive to reduce the user's learning curve, while precision ensure the adjustment can be made with higher accuracy and efficiency. Hygiene address how easily the interference can be sanitized. Finally, error recovery allows user to safely undo mistake or back out of action without negative consequence. Effective ergonomics performance is built in this weight evaluation. Digital control outperform mechanical control across 3 of 4 ergonomic pillars, while mechanical control excel in simplicity with a high score of 9 over 10. Digital control are clearly the winner for precision 10 over 10, hygiene 9 per 10, and error recovery 8 per 10. Ultimately, with a final score of 3 round to 1, digital interference provide a superior balance of accuracy, cleanliness, and user safety.
Moving on to our recommendations, our core finding for best economic solution is not to choose strictly between digital or analog, but to combine them. We propose a solution that integrates analog controls with digital displays to keep the mechanical knob, which provide tactile feedback and utilize muscle memory for quick adjustments. Besides, digital screens also visualize the exact temperature, time, and functions. However, different users have different needs. First, for commercial use, we recommend digital microwave since they prioritize precision, functionality, and repeatability over simplicity. Second, for home use, hybrid microwaves is recommended since it balances aesthetic and precision with the ease of use of mechanical knob. Third, for elderly and accessible design, analog microwave is recommended since it is simple and user-friendly. Moving on, in conclusion, a true economic study is not a choice between digital or analog. Thus, users have to choose a type of microwave based on their needs. Thank you.